uses shell method to find the volume of the solid form by revolving the region bounded by y equal to x minus x cubed. And the x-axis to make it simple, I'm going to tell you which part from 0 to 1. And we're going to rotate about the y-axis. So here, let me go ahead and draw you the picture. It's a little blurry. Let me fix that. Okay. All right, so we'll put 0 here, of course. 1 will be about here. 1. And we'll say 0.5 is here, and 1 is right here. Okay. So x minus x cubed, it may help to use the grapher, but let's go ahead and find it. Delete this from last time. X minus x cubed. There we go. So we're going looking at the 0 to 1 section. So it looks kind of like a parabola, a little curve on it. It looks like this is not quite at the halfway point, but whatever. Something like this, right? So I want to find this volume rotated on the y-axis, right? So what we said. Okay. So I'm going to slice this parallel to the rotational axis because I am choosing to do shell method, meaning I am going to do dx because it's going to be vertical, right? So the integral, let me see, make sure I have this all set up right. Well, actually, before you get to the integral, let's define the height and the rho. Okay. Oops, 1 second. So the height is going to be this guy here. So this is going to be my h of x. Okay. Now, the rho is going to be the distance from the slice to the rotational axis. So this right here, this distance is rho. All right. So I'm trying to make sure I get this correctly. H is there. Yeah. All right, so let's look at our notes here. to get this correctly together. So I'm doing dx, right? Because I have a vertical rotational axis. So let's go through this. Rho will be right minus left. So x minus a if the region is to the right of the line of axis of revolution. But our rotation is on the left, so it's just simply going to be x minus if the region is to the right. So the region is to the right. Yeah, right. On our picture, we can see rotation on the left side, so it's simply going to be x minus a. Now, what is a, right? A should be the rotational axis. So in our case, it's going to be 0 because we're rotating on the y-axis, meaning y equals to 0. Okay, does that make sense? So you're going to say the rho is equal to x minus 0 because the rotation is over here. The 0 is because this is the line x equals 0, technically. Now the height. Okay, the height would be similar to what we did before with the looking at the function itself. So the height will be the top of the axis. So here it is to the bottom. So the top is the function and the bottom is 0. So we're going to have, let me switch over. I guess I'll leave it there. So it's going to be x minus x cubed minus 0 based on these notes here. And I'm going to send that to you in just a moment. So do you see where this is coming from? So now we can just use the formula. So the volume will be 2 pi times the integral from a to b of p, or rho, times h dx, which is 2 pi integral from 0 to 1 of x times x minus x cubed dx. So we have to get, so rho is dependent on where the axis is. This guy is just the top and bottom of the region, just like we've been doing before when we were in 7.1 and 7.2. Very similar, the heights of the shells. Okay. All right. At this point, you would just integrate that and you'd be done. But at this point, I'm assuming you are able to integrate this. But I need you to grasp is where the heck is rho coming from? Where the heck is h coming from? Is there any questions about this part, this setup? Do you see where the integral bounds came from? 0 to 1. Right. Okay. Because it's dx of 0 to 1, right? Okay. Well, let's do another one. Example 2. Yeah. So as some x distance from the axis, correct? Axis of rotation. Sorry. All right. Example 2. So use the shell method. To find the volume of the solid formed by revolving the region bounded by x equal to e to the negative y squared, and the y-axis. And I'll go ahead and tell you the bounds from 0 to 1 on the y. And revolved about x-axis. Okay. All right. So I don't expect you to know what that graph looks like. So let's look at the graph here. Okay, so they said x equals to something, right? E to the negative y squared. Okay, so here it is. It's basically a sideways bell curve, right? And we're integrating from 0 to 1. So from here, go ahead and plug in some lines to show you. Y equals 0, y equals 1. So this section here to this whole little bounded section. Okay. So I'm going to try to draw that to the best of my ability here. So here's 1. So we have, and here's 1 over here. And there's 0.5, I guess. So we have something like this, I guess. Right? Okay. It's not very pretty, but who cares? All right. So we're revolving about the x-axis. Right? And we have 0 to 1. So our slice is going to be parallel to where the rotational axis, forcing us to do dy. So if I like, let's say I give you a test question, right? And I say, you know what, use any method. If you chose to do disk, you would have to slice perpendicular to the rotational axis, right? This way, which would then require you to solve for y because it's in terms of x equals. If I choose to slice this way, then I have to use shell because the requirement is that it's parallel to the rotational axis. So that's how you're kind of hinted at which technique to use. It's all based on where is the rotation axis, the axis of revolution. Does that make sense?
So if it's rotating around the x-axis, you use the shell method. And if it's rotating around the y, you use the disk.
It depends how you slice it. So if I slice this way and the rotation is on the x, then I have to do shell. If I slice this way, vertically, and the rotation's over here, then I have to do disk. So if my slice is parallel, shell. If my slice is perpendicular, disk. And you choose which way is better to slice. Remember how we showed those examples where sometimes when you're doing your rectangles, you hit the graph multiple times and you shouldn't. For example, we had, here, let me find it. I know it was a while ago, right? But like, let's say we had y equal to x equal to, that'd be better. You see how let me think. Yeah, let's say I wanted to find this area. If I were to slice this way, I would hit the parabola twice. the entire way. Let me think. Is that a good example? Yeah, so if I hit it twice, then that would be an issue. But if I slice this way, I'd hit the top of the graph and the bottom of the graph. Top, bottom. See how it's two different regions or two different boundaries? But if I hit the same boundary, I have problems. It's not going to work. So to solve this particular question, you can either cut it off here and take advantage of symmetry and just integrate from here to here to force the disk, assuming that your, let's say it's rotating on the x-axis, right? So if it's on the x and I want to slice perpendicular, which would force me to do disk, then I'd have to portion out only this section. But if I were to use shell, I would have to then be parallel to the rotation, which is on the x, which would be good because I can just go all the way up from -1 to 1 would be the integral, and I can just do my shell method. So it depends on the boundary and where the rotational axis. So you decide the slice, and once the slice is decided, then that will determine which method by looking at the rotation. Does that make sense?
Yeah. So just whatever way you orient the rectangle. So
Right.
either horizontal or vertical, just as long as it's not hitting the graph twice.
Yeah. So you choose whatever you want. Just make sure it's not hitting the graph twice. You'll be good. But once you choose it, then you'll be forced to do a specific method.
Okay, that makes sense. Thank you.
Mm-hmm. Okay. All right. So at this point, we need to figure out, since we have dy, let's look at our notes again. Because I forget sometimes too. Let me show you. So we have dy. So we look at top and bottom, right? So it's going to be y minus a if the region is above the line of revolution. And our region is above, right? Above the x-axis. So we'll just be doing y minus 0 because it's right on the axis rotation is actually the y equals 0 line. So similar to the last example, rho is equal to y minus 0. Height, right, is going to be the slice, so it'd be the right portion of the graph, right, minus the left. So that would be e to the negative y squared minus 0. So the integral will be from 0 to 1, because I told you 0 to 1, right, in the question. The rho times your height, dy. Does the setup make sense? Any questions on how we set this up? Okay, please let me know if you're confused or just something doesn't make sense, all right? I don't want to leave you in the dark. All right. This time, let's do a rotational axis that is, let's see here, somewhere different. Yeah, let's do this one. So eventually, I want you to be able to decide which method is best, because you're going to start to see that sometimes both methods or any method will work, but one method will be very easy while another will be a huge pain. Okay. So this guy, I'm just going to go ahead and draw it for you just to save some time. Because I want you to work on this homework for a bit, and then next time we'll go in depth and practice some more together. Something like this picture here. So let's say I'm going to rotate this region over here. Okay. And let's say that function is, let's see, what would it be? Where did I put it? One second. Forgot where I wrote the question. I think it was this. 1 plus minus. Ah, okay. Sorry, it took me a bit to figure them. I didn't write it down, apparently. Sorry about that. Okay, so the equation that makes this stupid thing is y equal to 1 plus x minus 2 root x. Okay. So it looks like this here. So this is a little section that we're zoomed in on. Okay. And we're revolving the line x equal to 1, I think. Yeah. Okay. So now we look at our notes, right? We're revolving not on a specific x or y axis. And we're doing shell method. So the instructions are use shell method to find the volume. I feel like I'm blurry right now. Find the volume of the region revolved around y equal to 1. Sorry, x equal to 1. Okay. So let me keep referring to these notes because that's what I want you to do. So we have since we're doing shell, I'm going to have to slice vertically, correct? So we're going to have dx. It's already solved for x, so great. So right minus left would be the row. But remember, if the region is to the right of the line of revolution, so it's not, right? We do x minus a. If it's to the a minus x, if the line of revolution is to the right of the region. This one is if it's to, I think I miswrote that incorrectly. I said the same thing, didn't I? Should be left. So our region is to the left, meaning we're going to use a minus x here for rho. So rho is going to be a, which is the line, 1 minus x. Let me double check everything. 26, 7. Yeah. Does that make sense, or is that confusing? All right, so then h will be the height, right? Then the distance from the region, from the axis to here, is 1 minus x. Height is the top minus the bottom, which is this function, 1 plus x minus 2 root x minus 0. And I'm going to integrate on dx from 0 to 1. That's for the rotation, it cuts it off. So it'll be 1 minus x times 1 plus x minus 2 root x dx. Does that setup make sense? All right, so I'm going to stop here, and I want you to practice the disk, shell, and washer, and bring me questions for Thursday. And if you don't have any questions, then I'm going to move on to the next section, the next 2 sections. If you do have questions, I'll probably just do 1 section. All right. So please review if you haven't. I know you guys had no power and stuff, so please review finding the area of a region, the disk washer, and then start this guy. And then we can work a bunch of homework problems on Thursday. Okay. I'm going to be pushing chapter 7 back. I don't even remember the original date anymore. Let me see. I don't think I had chosen a date actually. So I'm thinking we'll finish chapter 7 most likely Thursday or Tuesday of next week. Tuesday next week, or maybe this Thursday. And then we'll review next week. So the exam probably won't be due till not this Sunday, maybe next Sunday, the earliest, but probably later. To give you an estimate, it will not be before the 7th of March. Okay. But so since we had all those delays, we're barely in the middle of chapter 7, so we'll see how it goes. Oh yeah, let me give you this PDF real quick before you leave. There's a bunch of examples I'd like you to go over. I think it's also in the, just in case it's not, here, hold on a sec. This is 7.4. And this is 7.3. So please go over 7.3 as we did today. And well, there's more examples in there I didn't go over, but I want you to look at them. They're kind of interesting. And then I'll go over some homework problems with you, okay? I guess so. We'll do 7.4, 7.5 tomorrow or next time, and probably a bunch of homework problems. We'll see how it goes. If you have any questions, you're welcome to stay. If not, I'm going to let you go.